Mark Heim here, founder of Disaster Doc, sharing with you module number 7, volcano disasters. Let's go through the learning objectives together again. Once again, after completing this lesson, students will be able to define the term volcano, identify the two types of volcanic eruptions, describe the ring of fire, identify hazards associated with volcanic eruptions, also list the secondary disasters that could result from a volcanic eruption, list the major public health consequences of these volcanic eruptions, and identify measures that can lessen the health impact of volcano disasters. So what is a volcano? It's an opening or rupture in the planet's surface, or a crust, which allows hot magma and volcanic ash and gases to escape from below the surface of the Earth. So there are a few volcano terms here I'm going to share with you as well and kind of differentiate some of these as well. So some new words to add to your vocabulary. You can impress people and wow the crowd with these, but just to get us a little bit on the same page here. Number one is magma. Magma is molten rock that's below the ground. So people say, well, Dr. Keim, what's the difference between magma and lava? Actually, lava is magma that's above the ground. So if it's below the ground, they call it magma. And once it comes out of the volcano and hits the surface, then it's called lava. So that's the difference between those two, and you'll hear people use those interchangeably, but they're not exactly the same thing. There's another new term that I like to share with you as well. It's called Tephra. T-E-P-H-R-A, Tephra. And what that is gases and ash that are thrown into the air as a result of the eruption. So what we're really seeing is it looks like the smoke or the plume that comes out of a volcano. Tephra is that set of gases and ash that are in that plume. So let's talk about how volcanoes form. The melted material from the Earth's crust forms magma, right? That's underground. And this magma rises and gathers in a reservoir, a chamber that's still below the ground. And then many times this erupts through a crack in the Earth's surface. And these constant eruptions or repetitive eruptions build this pile of magma, this lava that continues to create more Earth, and it actually results in a volcano, that characteristic cone shape of a volcano. And there are two types of volcanic eruptions. One of them is called explosive, and the other is called effusive. And we'll talk more about those. They make a big difference in how dangerous these volcanoes are to people. Explosive volcanoes, just like it says, right? There's blast, there's heat, there's a lot of ash, and there's a lot of gas. And these things tend to happen very, very dramatically. And usually we find these associated with those subduction zones. Remember those plate tectonics I was talking about, where two plates come together on the Earth's surface and they press against each other. That pressure creates heat, and that heat melts the underground stone and creates this magma, and this magma then actually builds up in pressure. There can be gases that build up in that area, and when that erupts at these subduction zones, that's when you have the explosion. And so most of the time these explosive areas, we can actually pick them because they're close to these subduction zones. It's very similar to the way we know about earthquakes as well. So many of those are the same complete areas as well. There are also pyroclastic flows and tsunamis that are associated with these, and I want to talk more about pyroclastic flows in a minute. But just remember that these explosive areas are really the much more dangerous, and they can happen very, very dramatically. And an example of this, years ago, over a century ago in Krakatoa, when it exploded in Indonesia, that explosion, that explosive volcanic eruption actually destroyed most of the island. The island had a volcano on it, and literally by exploding, nearly blew away the entire island. So that's the explosive types of volcanic eruptions. In addition as well, we have this effusive. Now, effusive types of volcanoes, we see lava and gases, and we see much more, a moderate to type of release of this energy and these gases in lava. We usually see this associated with isolated chains. And so, for example, islands like Hawaii. Hawaii has an effusive volcano that's actually been erupting for over 10 years now, constantly kicking out lava. Sometimes it's pretty to watch, and it's actually, looks relatively dramatic, but certainly not explosive in that what we would see with these other much more dangerous volcanoes. The volcanoes that we've seen recently erupt in Iceland, the same kind of effusive model. Now, there is danger, of course, because there are gases and lava that can flow and so on, so we can't take those for granted of being, perfectly safe, but certainly not the kind of dramatic and explosive and very devastating kind of eruptions that we see with these explosive styles. And I want to talk now about that ring of fire that I mentioned before. That ring of fire is actually around the Pacific tectonic plate. So this tectonic plate, the specific tectonic plate, of course, encircles the Pacific Ocean. So on one side, North America and South America, the other side, Asia and Australia. And circling around that plate actually are a ring of this subduction zone itself where there's high pressure, and circling that as well, they call it the ring of fire because many volcanoes also live in that area. Volcanoes along the western coast of the United States, volcanoes, of course, in Chile, a current eruption going on right now as I'm actually filming this. In addition, also the Aleutian Islands and string down through Japan and so on in other areas of Asia as well. The ring contains over 75% of the world's active and dormant volcanoes. A lot of it's focused on that ring of fire. That's why I continue to bring that up for you so that we recognize where the danger lies in the world. Earthquake activity also occurs along these same borders, along that same tectonic plate. So the ring of fire associated with volcanoes, associated with tsunamis, and associated with earthquakes. So that one phenomenon, that tectonic plate and the subduction that occurs at that tectonic plate, that creates all three of these phenomena. Now, a hazard map, I've alluded to that in the past as well, and I've told you a little bit about it. I wanted to take the opportunity to share a hazard map with you. So this tells us where the hazard is located. Remember, as I said before, location, 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 right? If you live in that area, then you can be able to predict that there's volcanic eruptions that are going to occur, and you can see, once again, volcanic eruption is not these huge overlying areas, but they're repetitive. So you see these dots in this particular figure, which really shows us the individual volcanoes and what their risks are. And of course, especially in that Asian rim as well, on the border of the Pacific Rim where we see that occurring, we've seen some pretty bad explosions and volcanic eruptions, for example, in the Philippines or other areas in Indonesia have also been remarkably affected. And so we can expect that if that's occurred in the past, we can predict with some degree of certainty that that's going to occur in the future. That's the value of hazard mapping. Mapping where the problem is and then taking very concise efforts in that area. We don't have to plan for volcanoes everywhere in the world. We need to plan where the volcanoes are more likely to give us trouble. That's what the hazard map is for. So volcanic eruptions can be associated with various hazards, health hazards to you. And some of these actually, we're going to be new names for you. Some of them obviously you'll be able to recognize. Certainly lava flows. We know that lava flows are associated with volcanic eruptions. I mean, as a kid, we all learned that, right? We learned to watch the lava flows. In most cases, actually, lava flows become a problem, but they're not this abrupt kind of thing. Lava actually moves relatively slowly. And so in most cases, people can outrun lava unless it's a really remarkably different effect. Now, there have been examples where lava flows have moved quickly. For example, there was one lava lake that was in Zaire at one point in time, and the part of that lake wall broke, and that lava came down that hillside at 60 miles per hour. Now, that's very unusual for lava. Usually it moves relatively slowly, and people have time to get out of its way. It's a thick and sort of like moves like syrup, or as my grandfather would say, molasses on a cold day. So it's this kind of thing that moves slowly, but sometimes there are barriers that break and release lava relatively quickly. We still have to be concerned about 90 people lost their life in that lake rupture that I mentioned to you just now. Now, there's another phenomenon that are called pyroclastic flows. Now, there's a long word for you to wow your friends and astound your enemies with this particular flow. But what we're talking about here, pyroclastic flow at the top of a volcano. Volcanoes, of course, like that characteristic cone. And then there's an area, a rim up at the top, and it has this little area that they call a caldera. It's a little cauldron where the volcano, the lava comes out of it. And when lava is coming out of that area, of course, it's dripping over the side. But the other thing that comes out of that area, a lot of gas, a lot of debris, sometimes rocks and of varying sizes, a lot of ash is building up. And over a period of time, what happens is that ash actually starts building up on the rim of the volcano. So the ash gets higher and higher and higher. And they call that the dome. That pile of ash that builds up at the top of the volcano is known as the dome. What ends up happening, though, is what goes up must come down. And as that ash piles up, it's sort of like an avalanche occurs. So here this ash is actually 1,000 degrees, very, very hot stuff, builds up, and then all of a sudden it starts rolling down the hillside. When it does, you'll see that this ash is just barreling down, usually moving very, very fast, much, much faster than lava. This is the big killer when we're talking about volcanic eruptions. Pyroclastic flow have taken many, many lives because it happens without very much warning. The volcano may be going off for days, for weeks. People at the bottom of the hillside staying there, hoping that things are going to get better. Next thing you know, this dome collapses. And when the dome collapses, it comes down in a pyroclastic flow. It's very, very hot. It's moving very, very quickly. Now, I've seen the effects of this actually in my work as well. I've gone to places, for example, one of the first volcanic eruptions that I ever went to as far as a disaster response was in Montserrat, the Caribbean island. And they had the same phenomenon. For a while, the volcano was dormant, meaning it was sort of sleeping and not a lot of gas and ash coming out of it. And then it started working up a little bit. And then finally, they started having days where it really started erupting. And it developed that dome up at the top as well. And then one day, that all came barreling down, and when it did, it covered the capital city of Montserrat. It covered the entire city, many lives lost. A lot of people had to be evacuated, and they really suffered in that example because they lost their own capital. They had just built a new 5 or 6 story hospital. The whole thing wiped out. Many people displaced in that particular area. And so it was this pyroclastic flow. The folks that were involved in that, if you were hit with that flow, it was almost instantaneous that people would be killed. Also, that pyroclastic flow, when it comes down, that ash spreads out over a long period, a long distance, and stays hot for a long period of time. And because of that, actually, it's a danger as well. That stays to be 300 degrees, Fahrenheit, which is cool for a volcano, but that's still as hot as your oven. And so unfortunate people would get trapped, and they try to walk in that ash, and 300 degree temperature ash on your feet and so on. It really has people isolated, kept a lot of people from being able to get to aid when they needed it, and a lot of severe burns. So we have to be careful about that pyroclastic flow when we're living near these volcanic eruptions, and think about it as well. Now, there's another phenomenon that are called Lahars, another new word for you, Lahar, right? And what a Lahar is actually many of the volcanoes are high enough up in the atmosphere to where it's cold. And so actually the precipitation that is lying on top of that mountain or that particular volcano is snow. And so when the volcano starts heating up, of course, the volcano's heating up at the top, and that snow starts to melt. And when it melts, it comes down in rivulets. It comes down in certain areas and low inclining areas, and it becomes a mush of ash, and it becomes mixture with the water of the snow. Sometimes it can hit lakes or other streams and so on, and that follows the low-lying areas down. And so what you have is you have this flood of lahar, which is actually ash and debris mixed together. And because that ash is actually rock, that ash is really just fine particles of rock, when a lot of that rock mixes together with water, it's extremely heavy. And when that comes coming down the mountainside in a flash flood, you have this thing where it's very, very heavy and it just knocks down debris. So lahars kind of act like a tsunami. Certainly not as strong and large as tsunamis can be in other areas of the world, but the lahar does carry a lot of destruction when it starts coming down the mountain. One of the worst lahars in recent history actually occurred in Colombia. And for example, this particular village was 25 miles away from the volcano, so you could see it erupting over off in the distance, and people never dreamed that they had any type of threat from that volcano. But what they didn't know is there was actually a ravine that went from the top of that volcano down, followed a riverbed, and actually came to that particular village, that particular city. And so the people thought that they were safe, relatively safe. People went to bed that night, and that lahar occurred. And when it flowed all the way down. 25,000 people in that city were killed, all as they slept, buried under that lahar. And it was remarkable tragedy and loss of life. But once again, this issue of lahar. So we can model that. We can tell the low-lying areas near volcanoes and be able to prepare for that. And actually, there are a few of those in the United States as well. For example, Seattle has a potential for lahar as well there, and that's been modeled out, and they know where these dangerous areas are. So people near that area, if there's a volcano and the volcano starts to erupt again, now dormant of course, starts to erupt again, they need to be concerned about getting out of the way of those lahars. Now, the other thing that happens with these explosive style of volcanoes are these blasts and projectiles. So the explosion itself can actually create a sonic wave, a sound wave that it causes damage. So it's like you're standing there and the air hits you so hard that it actually injures you. There have been the blasts from, for example, Mount St. Helens, the eruption in the United States a couple of decades ago, actually knocked down trees for 6 miles. And when you look at that, flew over the area, all the trees actually going in a straight line where they had all been knocked down in the same direction. So that blast literally just knocked down the forest all at once, just as though it was toothpicks. And so these blasts can be dangerous just by themselves. However, they also carry projectiles with them. They throw out rocks. Some of these rocks are pretty good size, big as a car, big as a truck. And these projectiles then become dangerous, of course, if they come down and hit you, or they're also hot. They may start fires and so on. So the projectiles themselves can be dangerous, another hazard associated with volcanic eruptions. We also talked about tsunamis before, and we said that volcanic eruptions can actually cause tsunamis, and they can also cause earthquakes as well. So a volcano goes off, the explosion can create an earthquake, make the earth shake, actually can cause significant damage. And a volcano, if it's associated underwater, when it explodes, can also cause a tsunami. Now that happened years ago in Krakatoa. Mount Krakatoa at the time was a volcano eruption in Indonesia. And this thing started going off and building, and then all of a sudden it just went boom. And literally this whole island exploded. When the island exploded, it nearly wiped out all the entire island. And this resultant tsunami actually killed more people by the tsunami than the actual volcano itself. So once again, these things are very, very dangerous. The next thing that happens with volcanic eruptions that we see this association is this Tephra fallout. You know, this plume I was telling you about and all this debris and ash that go up into the air, and we see these plumes rather dramatic. And certainly the one happening now this year in Chile, same issue as well. Tephra, it's going for a long distance, and there are a lot of problems with that Tephra that not only just because of the air pollution, but because of the other kinds of problems that occur with that, and it can go for miles and miles. For example, in Montserrat in the Caribbean and Caribbean Ocean, we actually saw the Tephra go from one country to another. So it not only affected Montserrat and had a lot of dust that came out and affected agriculture and so on in that particular country, but actually nearby countries had bad air because of that as well. And so respiratory problems and things that complicate that as well associated with that Tephra fallout. We also see acid rain associated with volcanoes. So this Tephra, it's going up into the air and it's carrying acid into these particles, and it's carrying it in the air. And then when that rain occurs in other areas, it actually comes down and poisons the forest. It poisons gardens and things like that. So acid rain is a big issue when related to volcanic eruptions. Not always a problem, but can be a problem if you're looking at especially places where this may occur on a frequent basis. We also see other things like gas emissions. So not only are there particles that are in this plume, but the gas that comes out of these volcanoes can also be dangerous as well. There can be mixtures of gases in different concentrations and so on, and merely the gas itself, let alone the dust and the particles that are carried with it, can also be hazardous to your health. So let's talk more in detail about these lava flows. Lava, as I mentioned, generally moves at a slow speed, allowing for time for evacuation. And I talked about that issue in Zaire as well, where people just didn't have time to be able to evacuate. They were trapped, and there was a loss of life of about 90 people in that particular event. These pyroclastic flows, once again, very dense clouds of debris, hot gases, they're fine pumice, there's ash and rocks, and they move primarily due to gravity. I told you about the dome collapse that occurs. And the thing about this particular pyroclastic flow, 900 degrees centigrade. You're talking about something that is very, very hot when it's created, traveling at speeds up to 100 miles per hour. There's no way to get away from them. You just have to evacuate people ahead of time. So that's a good review when we're talking about this pyroclastic flows. Let's think in terms of that Lahar as well. I like to think in terms of the mud flow or the mix of water and volcanic debris, but it's very dense. But usually it travels at about 20 miles per hour, relatively slow, but early warning is crucial with those. So once again, early warning comes into play, just the same as we're talking about predicting volcanic eruptions and so on. As I mentioned, the volcanic blasts and projectiles, a blast wave can travel over 6 miles from the vent itself, can cause multiple fires, blunt trauma, and so on. So that's a good thing to keep in mind when we're talking about trying to evacuate people to the appropriate distance away from these particular events. This Tephra fallout can occur. Millions of tons of pumice can actually go up into the air when this happens. I also want you to keep in mind that this Tephra carries with it not only silica and fluoride and other types of minerals that can poison water sources and food sources. Sometimes Tephra actually brings radioactive compounds that were previously buried deep down in the earth and can spread those out as well. So we have to be concerned about some of the issues or about radioactivity related to this Tephra. Now obviously it's not as hot and high as we would see, for example, at a nuclear reactor, but there is some danger for that, and certainly the experts look for that when they're evaluating these types of disasters. Also, the thing to keep in mind about this Tephra is that it's very fine particles. So, for example, in Mount St. Helens eruption in the United States, 90% of plume particles were small enough for people to breathe deep into their lungs. Now there's a fine line of what will actually stay in your lung when you breathe in. If a particle is too big, actually it gets stuck in the back of your mouth and back of your throat and you can cough it up, and it doesn't get down deep in the lungs because it's a little too big to do so. If it's too small, actually what will happen is sort of like some cigarette smoke. Breathe it in and it comes back out of your lungs and comes back out again because it's so small. But there's a fine line between the two that actually once they go in, they go all the way down into your lungs, but they stay there. And that's what we see. They call that a respirable component. And what that portion of the Tephra that's that size, that stuff tends to get down deep in the lung and doesn't come back out. It can trigger other types of reactions. You can have other types of inflammations. You can also have an infection of pneumonia as a result of those breathing in that Tephra. So once again, respiratory protection, big issue, especially not even people that are very close, but can be hundreds of miles away and still getting a lot of that respirable component, those small particles that you can still breathe in. So we have to be concerned and warn people about that. And how do we do that? Well, we tell people, try to limit the amount of work that you do outside. Postpone the sporting events where people are outside and so on. Try to stay indoors, especially if you have lung or heart problems. We want to keep people out of those kinds of conditions. I also mentioned this issue of volcanic acid rain, and I want to revisit that with you as well, take a little bit deeper dive in that one also. Higher than normal amounts of acids in the air that resulting from these volcanic eruptions also damage vegetation. They poison surface water, and high acid levels can actually cause skin and eye irritation during the rain. And actually, this is acidic enough to dissolve some sheet metal roofs. So in the Caribbean, actually, a lot of folks have sheet metal roofs on their homes and in their villages and so on, and this causes it to dissolve faster. Now, of course, it's not dissolving in front of your eyes because it's not that strong of acid, but over a period of time, if you live in an area that's exposed to that, actually it causes people to have to replace their sheet metal or other metallic things, cars and other vehicles and so on, that may actually wear out faster because of this exposure to this volcanic acid rain.